standard deviation, we're going to use what's called a z-score to tell people where a number is in relation to the mean. So what we're going to tell them is it above or below, and how many standard deviations it falls away. And this is going to come in really handy when we get to the normal distribution, because this is how we're going to calculate probabilities. So a standard score, or a z-score, again, tells people how many standard deviations a value is away from the mean, and also is it above or below. And this is the formula right here. It's called a z-score. So it's z equals x. So this is whatever your data point is your x. So whatever number you're trying to standardize. Mu, of course, is your mean. And then sigma, of course, is your standard deviation. So what you're really doing is you're standardizing a score. So if I made a graph of heights, it would clearly be different numbers than a graph of weights. But what I'm going to do with the z-score is I can standardize them both to the same scale, and then I can use a table of values or my graphing calculator to calculate a probability. So we're standardizing everything. Or if you want to compare your ACT score to a friend's SAT score, the scores are totally different. So what we want to do is standardize them, put them on the same scale, and then we can compare them more easily. If it's a sample standard deviation, notice the only difference is it's an X bar and it's an S, because we have sample data. So it's always going to be your data point minus the mean divided by the standard deviation, and you've got a z-score. So if the mean score on the math section of the SAT is 500 with a standard deviation of 150, what is the standard score of a student who scored a 630? So our z-score, remember, it's going to be our data point minus the mean divided by the standard deviation. So in this case, our data point is 630. This is the number we're trying to standardize. So we're going to take 630 minus the mean. Here's the mean. Make sure you hit equals, and then divide by our standard deviation, which is the 150. And we get approximately a 0.87. So what that tells us is if you scored a 630 on the SAT, you were not quite one standard deviation above average. Okay, this time we got two students here. Jody got an 87 on her calc test. Her class had an average of 80 with a standard deviation of 5. Ashley got an 82. Her class average was a 73 with a standard deviation of 6. So who did better compared to the rest of the class? So first glance, you're like, well, Jody got an 87. She clearly did better. But what we want to do is compare them to the rest of their class. So we're going to have to calculate a couple of z-scores here. So for Jody, we'll put a J here for Jody, her z-score is going to be the score she got, the 87, minus the mean, which is 80, and divided by the standard deviation of 5. So that's going to be 7 divided by 5, and we get, well, not approximately, it's exactly 1.4. And get in the habit, this one came out nice and neat to 1.4, but round these to 2 decimal places. The only exception you want to round to 3 is if you get something like 0.795 and it stops right there. So if you have a third digit that's 5 and nothing after that, then go ahead and keep all 3 digits. But other than that, always round these to 2 places. So now you guys pause this and go ahead and do the same thing for Ashley. Okay, so hopefully for Ashley, you said you're going to take her score of an 82, subtract the class average, 73, and divide by the standard deviation, and she gets a 1.5. So Jody is 1.4 standard deviations above average, whereas Ashley was 1.5. So Ashley really had the better score relative to her class.